Welcome back to The Build Show. I'm Travis Brungart, and I'm here with my good friend Voya, talking about what's new in HVAC. I'm pretty excited to show off that I'm using some new stuff. We got a fun conversation about what's new in HVAC. Check it out.
Come see Travis Brungart at Build Show Live, scan the QR code, or click the link in the description for tickets. Use code Travis26 for 25% off.
So, Voya, when I heard you were coming in town, I got pretty excited because we've got this house that Energy Vanguard did the HVAC design for us, and it's got LG all over it. And now that you're there, I wanted to make sure that you saw what we were doing.
Yeah.
And when you pulled up, I was like, oh, I'm going to go get the branch box. Voya's going to be so proud of me. We talked at summer camp.
Welcome to the club, buddy.
Right? I was like, oh, new tech for me. I'm putting in my first branch box. And then I said, how long have these been around? And you said, what?
Well, about 10, 15 years to be safe in the U.S.
I'm right on the cutting edge, baby.
You are absolutely on the cutting edge, my friend.
Oh,
but you know what? From an adoption standpoint, just because something's been around for a while doesn't mean that it's been adopted. So from an adoption standpoint, this is going to be new tech 10 years from now.
That's right. It's
We're
always new
going
to
to have
somebody.
plenty of markets that, exactly, it's just like a car. It's new to me.
Well, this was new to me because we've always done these one-to-one systems. I got one outdoor unit, one indoor unit, one line set connection.
Yeah.
Very simple. Well, this house has...
You've got a lot of windows and not a whole lot of space to put outdoor units on.
Yes, and we have a U-shaped design. The house is kind of a horseshoe around a courtyard, and it has a lot of units, man. I've got 4 units. So in order to serve that, Jeffrey over at Energy Vanguard did a nice design, and he said, hey, how about this? So talk me through, what am I doing here? Explain what this does.
Well, this is outstanding. So everybody in the market has heard of zoning.
Right.
We're just used to zoning our air, right? Dampers to push air from one place to another. You're still running the whole system at full speed. You're just kind of robbing Peter to pay Paul when it comes to the air side, right? So what you're doing here is you're zoning through refrigerant. So what we're gonna see here, and yeah, that thing's heavy enough, you don't have to hold it. We know you got muscles, whatever you're saying.
Thanks, buddy.
So what this heat pump, and I love the fact, and we'll talk about it in a second, I love the fact that you picked a cold climate heat pump. But what this heat pump is gonna do is it's gonna send refrigerant from this outdoor unit to this branch box, and then the branch box is gonna communicate with the indoor units. And we can do anywhere from 2 up to 8 indoor units on a set of branch boxes. So, you know, this will do up to 4.
Right.
You want to do 8, you just do 2 branch boxes.
Okay.
This unit sends refrigerant to those branch boxes. And based on what each indoor unit is asking for, capacity-wise, this branch box is going to deliver just refrigerant to that indoor unit.
So it's distributing based on load. It's not one uniform load goes to all. It's not like the manifold on my old ductwork would be like, hey, you're going to get all this.
Absolutely.
Okay.
It's doing exactly what your plumber has been doing for decades, right? When you're in the kitchen and you open up your hot water or you open up your cold water, it only gives you the water you want at the temperature you want, exactly where you want it. Your shower's not going off. It's not an all or nothing.
Thank goodness.
Right? Thank God. So this is exactly the same principle. You're simply allowing the indoor conditions to dictate what amount of refrigerant goes from this unit to that branch box into the indoor units. So I can have one room set to 68 degrees and one room set to 73 degrees, and they're both going to maintain because they're both getting only as much refrigerant as they need.
That's perfect.
Make sense?
Yeah. Now, what were you saying about my cold climate unit? Because I didn't design this. Jeff designed it.
I love it. So, okay, so this is magic. So we're not going to go into like the detail exactly how it works. So we got to leave a little bit of
dumb it down to my level.
Right. Well, pretty smart guy, even without a beard. But what a cold climate heat pump does is exactly what its name intends, right? It works as a heat pump more efficiently in cold climates.
Sure.
So let's say typically one of the biggest myths I hear about heat pumps don't work.
That's an old myth, yeah. We hear it a lot.
Why don't heat pumps work? Well, because anytime it drops below 45 degrees, the heat pump cuts out and you're basically heating on your electric strips now.
Right.
True. 40 years ago. But for the last
That's even before they came out with the brunch box, right?
For the last 20 years, we've had inverter technology that allows you to actually heat efficiently and effectively with a standard heat pump down to like 17 degrees, 15 degrees. and still get 100% capacity.
That's
out of
crazy
that heat
efficiency.
pump, but that's standard. In come cold climate heat pumps. These bad boys, depending on the unit, depending on the manufacturer, will give you 100% heating capacity down to either 5 or -5, will give you like 80% capacity almost.
Really?
And this is, again, plus minus, don't quote me exactly on the numbers, but it's pretty damn impressive performance at -13.
Well, I'm in Kansas City. We don't have a ton of time at -13.
Don't.
But we did have a week where several times we were -4, -2, and we have long periods of time, weeks at a time, that were below freezing. So that's a really nice thing.
So aren't you glad that you had it?
I am. I'm thrilled. And as the electrician, I'm thrilled that I didn't have to run a bunch of big cable to add heat strips to an already efficient unit.
Yes. So even in those extreme conditions that we may get every 10 years or so, right? I'm in Texas. 2021, we had like 3 days at 9 degrees. Yeah. Okay. I had a standard inverter heat pump in my house with 5 air handlers, no electric backup anywhere, and I still maintained comfortable levels inside the house.
Nice.
Now, mind you, standard heat pump, I couldn't maintain 72 degrees in there, but I maintained 67, 68.
Which is very comfortable.
Pretty freaking comfortable, right? This unit would have maintained that 72 degrees without a question.
Nice.
And here's the crazy thing. We now have some smaller units that will actually give you 100% heating capacity at -13 and upwards of 70+% heating capacity at -31.
So all of our friends up in climate zones 7 and 8, call Voya.
They're gonna love it.
Yeah.
Right? So technology is continuously evolving. So to your point, it may take 20, 30 years before that's widely adopted across the board, just like these bad boys, but it's new to you.
That's right. It's new to me. You know what else is new to me? When we talked at summer camp, you were telling me about what you did at your house.
Yes.
And you guys, we don't do a lot of radiant in Kansas City. It's because we require air conditioning, and radiant is typically a heating only delivery for what we're used to. You know, tubes running through a thermal mass of a concrete slab.
Yep.
Great way to deliver radiant, but it's very slow to respond. There's a thermal lag. And this morning, it's 47 degrees, but this afternoon it's going to be 75. So I'm going from heating to cooling. And that is going to happen over a 5 to 6 hour period. For you, you're a cooling dominated climate in Houston, right?
I'm in Houston, man. I'm just outside of Houston, so we are climate zone 2A all the way. 105 degrees outside with 98% humidity.
So why are you doing radiant? What are you doing down there? What's new in heat pump tech that you can make this work?
We want to do this one right now?
You want to go inside and do it? I know you're chilly.
I mean, I'm freezing my butt off. Yeah, like I just said, I'm from Houston.
Let me take my fancy new branch box that's cutting edge, and I'll go inside and we'll talk about this.
I'm going to go warm up even with my warm vest.
Come on. All right, so now that we're inside of this warm, toasty space.
Yes, I'm not freezing my butt off anymore.
You won't be so distracted.
I appreciate you.
Why don't you explain to me what you're doing? Because obviously we're showing air-to-air heat pump technology here, but that's not what you're using on your house in Houston. What is it that you described? Monoblock system? What is this?
What I decided to do at my home is to test out and see how can I play with air-to-water technology in a climate zone 2A, right? So air-to-water is not new.
No.
Air-to-water in residential has been around for decades.
Okay.
Right? We have boilers.
So it's as modern as my branch.
It's just as modern, yes. So we've had boilers for 100 years plus, right?
Yeah.
And that's what we think of when we think of hydronics here in the States, right? Because you get a massive energy benefit from moving water through large thermal mass, right? Either in-floor loops or radiators. That thermal mass is what gives you the benefit. It has the ability to hold that temperature much, much longer than air.
Yeah.
And then it slowly radiates and releases that temperature, gives us a nice comfortable space.
Right.
That's what we're used to. Fast forward to, 10, 15, 20 years ago, Europe and Asia, they get air to water heat pumps. So just like the unit we saw outside, except instead of pumping refrigerant inside the space, it pumps water.
Okay.
And again, they're still using it predominantly for heating applications.
Yeah.
Because of that thermal mass. So what I decided to do is let's try to figure out how can we apply this, and does it actually make sense to apply this in a cooling predominant climate as well? Because all I'm doing is I have a heat pump, right? So it's not capable of just producing hot water. it's capable of chilling water as well.
Sure, you're just moving heat one way or the other.
That's it. That's all I'm doing is I'm just moving heat. I'm not producing heat. I'm moving heat. So what if we could connect that to a hydronic air handler, which we've had in commercial applications for decades?
Yeah.
But here's some benefits that I get. Remember I said I'm in climate zone 2A.
Right.
Very hot, very humid.
Yeah.
Dehumidification is my key.
100%.
Right?
You need that cold coil, buddy.
Absolutely. And I can't quite get that without overcooling my space with traditional air conditioning systems. So, can I use a dehumidifier? Absolutely. I have a Santa Fe that's getting installed in my house. I absolutely love the product.
Yeah, it's great systems.
I love the fact that I can talk to our friend Nikki, and she can help me if I need design.
Sure.
But I said, what if I could manipulate the air in my system? What if I could see how much energy savings I can get? So we installed the system with a 5-ton air handler, in which I can slow my fan speed down to 100 CFM a ton or even lower. I just chose to go to 100 CFM a ton. But I'm not worried about freezing my indoor coil. I'm not worried about little problems like oil return and refrigerant velocities and minimum capacity on the outdoor unit and making sure that I'm exactly sized the right way that I need to be for the space. I can actually be slightly oversized because now I can modulate outside my compressor. I can modulate the pump that delivers water inside the space. And that gives me everything I need to run my indoor fan the way I want, not the way the system dictates. So what I've seen in heating, I've seen coefficient of performance of 5+, which is ridiculous.
That's kind of unheard of, right?
Right?
We don't see that.
We don't see that in DX systems.
Yeah.
But in an air-to-water system, absolutely achievable.
Really?
I haven't quite gotten there on the cooling side yet because we are still kind of trying to fine-tune some controls to just tune it in. But what I can tell you is the lowest I've seen has been about 3.5.
Which still beats me. I'm 2.5. Maybe I sneak 3 here and there.
All we're doing is, remember, we just said we're moving air or we're moving heat from one place to another. So if I can achieve a COP of 5+ in heating, you bet I can achieve a COP of 5+ in cooling, which now makes that system incredibly energy efficient.
Yeah.
Incredibly quiet. There's no refrigerant anywhere inside my house, so I'm not worried about refrigerants changing, right? Because I have a very small amount of refrigerant in a closed system outside the house.
Yeah.
All I'm going into the house with is PEX pipe with water, right?
Yeah.
But I'm able to maintain humidity levels in the space without overcooling the space, which is traditionally what you do, right?
Yeah,
if you look at your DX system, you set your thermostat and you say, okay, I want to be able to dehumidify with my AC system. Not as efficient as a dehumidifier, by the way.
Of course not.
But in a pinch, it'll do.
Yeah.
Okay?
It does perform that function.
It performs the function, absolutely.
Yeah.
But what's the kicker? You have to tell it. How low am I going to let you go?
Yeah.
If it's 70 degrees in the space and that's my set point, I'm going to let you get down to 68 degrees in the space before you go, okay, I need to stop cooling now, regardless of whether you've reached your dehumidification set point or not.
Sure.
That's just the way the DX systems operate.
Yeah.
With an air to water, I can move so small of an amount of air across the coil that I can dehumidify without ever pushing in so much air into the space that I overcool.
Okay. So that's what's new in the tech is the ability to achieve this goal that we're all going for anyway.
Absolutely.
But you're delivering it at a much better coefficient of performance and without the overcooling.
Yes.
And without refrigerants inside.
And with a much, much smaller amount of refrigerant in the system total.
Which is a huge cost
We're
benefit.
talking maybe like
benefit.
a couple of pounds of refrigerant as compared to like 10,
6,
14,
7,
some
15,
systems.
yeah.
Exactly, right? So that's much, much better for the environment.
Of course.
It's much also better for cost because let's face it, last time I checked, a jug of 410A was pretty expensive.
Yeah.
A jug of water didn't cost me nearly as much.
The water is much more affordable.
It's a whole lot more affordable.
All right. Well, I'm still going to be proud of my branch box as new tech to me. And you can be proud of your monoblock.
And maybe in a couple years, we'll put a monoblock here. We'll be here talking again.
You'll drag me along into the future.
That's not all that's new, man.
What else you got?
Heat pump water heaters. We've
yeah.
heard about heat pump water heaters.
They've been around a little bit, yeah.
They've been around for a while. The main difference is what you have is you have a water heater manufacturer that buys a heat pump compressor and slaps it on top of a tank.
Right.
It's worked, but it could have worked better.
In terms of efficiency or?
Efficiency, reliability, performance, cold weather performance, all of those things, right? Noise levels.
Yeah.
What happens when a compressor, inverter, heat pump compressor manufacturer says, well, this is the more complicated piece. We can just take this and slap it on top of a tank.
Yeah, okay.
Now you get a heat pump water heater that performs down to 20 degrees ambient and still runs on heat pump, which is unheard of in heat pump water heater world. It performs at decibel levels of 42 decibels, which is
pretty quiet.
A fridge.
Yeah.
It's super, super quiet. Again, unheard of. And it does so with an inverter compressor that's able to deliver faster recovery and a larger volume of hot water out of a smaller tank. So it'll actually fit in those tight spaces that you get to play with.
There you go.
Every single day.
That's a nice way to put it.
And it helps dehumidify the space inside as it operates. And one thing that we know is when we start building tight homes, our load ratio shifts, right? Our sensible load goes down. That's the temperature we can feel. But our latent load, which is moisture in the air, goes up. Because right now, as we're sitting here talking, we're producing moisture.
Of course.
If we have plants in the house, we produce moisture. God forbid you put a fish tank in here. That's a lot of moisture.
That's for someone else.
Right? Now we have a piece of equipment that is not our air conditioning, that just simply helps dehumidify that space a little bit, helps take care of some of that latent load, making the space inside more healthy, more energy efficient, and more comfortable.
That's a great value add. You guys are cutting edge on all kinds of stuff.
Everything heat pumps, baby.
Everything heat pumps.
Dryers, like clothes dryers.
We just put one of those in yesterday.
Right? And I want to go see it.
Yeah, we'll go
to that house.
Let's go there next. I got so many things I want to talk to you about. It's always so much fun to talk to a friend about these wide-ranging issues, especially someone that knows all the stuff that you know. So
absolutely, dude.
We'll be back with another episode coming soon. More wild stuff with Voya. But thanks a lot, man. I appreciate you bringing me up to speed.
Buddy, maybe next time you can come down to Houston so I don't have to freeze.
I'll sweat with you. We'll do it. Thanks a lot.